Now, we begin to say that when a free enzyme binds reversibly to a substrate, now it produces an enzyme-substrate complex. And now this enzyme-substrate complex binds irreversibly now to produce what? E plus P. E is the free enzyme, P is the product. So that means when we are talking about free enzyme bind reversibly to a substrate, it simply means that there is what? Forward and what? Backward reaction. I hope that makes sense. Now, during the first reaction, which is this plus this to produce this is the first reaction. This is the second reaction. Now, during the first reaction, we have the rate of formation ES. ES, remember, ES is what? Enzyme substrate complex. Now, concentration of enzyme substrate is equal to rate of breakdown, which is what? Enzyme substrate complex. Because now E plus S will form ES. And now, for us to break down, we are saying that ES will break down to form what? E and what? S. I hope that makes sense. Now, we begin to say that we have what we call K1. Now, for the first reaction, which is the formation E plus S to form ES, we are having the constant here, K subscript 1. K subscript 1. That's what you are saying in the first one, in the first reaction. That is during the what? The forward reaction. In the forward reaction, we have that, K1 concentration, E concentration, S. K1 concentration, E concentration, S. That's the reactant and the what? The constant. So what it takes to form is what? E, S, and this constant. Now, for the breakdown, of course, what do you think is the breakdown? The breakdown now, this will be what? Our reactant in our breakdown, because it's not coming this way to form E and S. So for the breakdown, we're having K subscript minus 1, which is the constant in this what? In this backward reaction. Concentration what? ES. I don't know if you get what I mean. Now, if we've gotten this, that's formation and then breakdown, we're going to say that we have concentration of E, that if we want to continue solving now. Now, for us to actually make, this KS, the subject formula, we can equate that concentration E, that's free enzyme concentration, substrate concentration, will divide by ES. Are we getting what I'm saying? Because at the end of the day, we want to put all the constant one side and then get our, enzyme substrate and enzyme substrate complex one side. So doing that, we are going to divide by the coefficient of K subscript minus 1, which is ES, divide by the coefficient of free enzyme and substrate, which is K1. So we are going to have something like this. Concentration E concentration S all over concentration ES will be equal to K subscript minus 1 all over K1. Are we together? Now, remember that the whole analogy is just to explain that enzyme binds to substrate to form what? Enzyme substrate complex. And then in further reaction, which is what is now what? An irreversible reaction, we're having free enzyme plus what? Plus product. Now, at this point, we are having that K subscript minus 1 all over K subscript 1 is equal to Ks. And this Ks is what we call dissociation constant. You can write it down. We call it dissociation constant. Now, in further reaction I'll be showing you, we call it Michaelis Menten constant. This is equation 1 actually. Ks equals concentration E concentration S all over what? Concentration ES. Where E is the free enzyme, S is the substrate, ES is what? Enzyme substrate complex. So from this particular explanation, we've gotten our equation 1, which is Ks, dissociation constant, equals concentration E, concentration S, all over what? Concentration ES. Now, continuation, we say that for total enzyme you can write it as E subscript T, but here we are saying E subscript 0 is equal to free enzyme plus enzyme substrate complex, whereby our free enzyme is E, and then our enzyme substrate complex is what? ES. Now remember that the whole stuff, what we are trying to do here, I want to make my E subject of the formula, my free enzyme, so that I can impute it in this reaction and show you another thing. I know you understood from here. I want you to follow me now. Now, since we've gotten our total enzyme, which is E0 equals E plus what? ES. Now, we'll say that to make this E, which is the free enzyme, the subject of the formula, of course, you know what to do. You collect lifetime. This ES, move over here to be E0 minus what? ES. And that's what you are seeing here. E, which is the free enzyme, is equal to what? E0. E0 is what now? You got it right. Total enzyme. Do you understand? E0 minus what? ES. Concentration. All of them are in concentration. This bracket you are seeing here simply means that this particular, enzyme substrate complex is what? Is in concentration. Are we together? Now, substituting this in equation 1.0, that means anywhere we see E, we put E0 minus ES. So in this equation 1, we have Ks, K subscript S, is equal to concentration E concentration S concentration all over concentration ES. So that means this is our E. So anywhere we see E, substitute now, we'll now put this value. E is equal to E0 minus ES. So substituting this value in equation 1, we are saying that Ks will be equal to, instead of writing E concentration E, we'll now say E0 minus ES. And this is when we can bring in double brackets. I hope that makes sense. Or single bracket, not double bracket rather. So this is when we can say E0 minus EX multiplied by what? Concentration S all over ES. So the first thing you can do is to what? To open the bracket. Now opening the bracket, we'll now say, remember we say concentration E0 minus concentration ES, concentration substrate all over what? Enzyme-substrate complex. Now what we'll do here now is that we say, opening bracket, we'll now have E0 multiplied by S. We have concentration E0 concentration S, and that's what you're seeing here. Now minus ES multiplied by S, we now have concentration ES concentration S. ES is enzyme substrate complex, S is substrate, E free enzyme, and E0 is what? Total enzyme. Now we now say that Ks, already you've seen how we've gotten this, E, this, and all that. Now we now say that cross multiplying to make ES the substrate of the formula, because we want to make this particular ES the substrate of the formula. So we cross multiply. We will not be having something like this. Cross multiplying will be having something like this. So cross multiplying now, we will now have Ks ES. That's what you are seeing here. Ks ES will now be equal to everything here. So now, if we've written it this way, we are going to collect like terms. Now collecting like terms, remember for the first one we made our Ks substrate of the formula, which is our equation 1, and then we got our total enzyme. We made the free enzyme the substrate of the formula, and then we replaced the free enzyme. We substituted the value of the free enzyme in equation 1. Are we together? Now we'll continue solving after we've equated. Now what we are trying to achieve is so that we get a new ES, enzyme substrate complex. Are we together? We have an enzyme substrate complex as a subject formula. That's what we'll continue to get our Michaelis Menten equation. So after we've cross multiplied, we'll now collect like terms. Collecting like terms simply means already we have KSES. Now, what and what looks alike? You begin to see that ES is at the left hand side, ES is also here. Is there any other place you're saying ES apart from here? So this is the two ES. So what we do is that this particular man here will come over here, will move and enter here, and this man will stay there. So now collecting like terms simply means that negative will come over across equality sign to turn to positive, and that's what we begin to have KSES. Instead of having negative, now since it has crossed equality sign to be plus concentration ES concentration S equals, now we're having E0S. I don't know if you're getting what I'm saying. Now I said KSES plus ESS. This is done. Now equals E0S. Now rewriting this particular stuff here, this particular stuff here, we can say there are two things that are common here, which is what? ES, and that's what made us to change it from there to here. Now there are two things that are common here, which is what? ES. So we can bring out ES, and when we bring out ES, we are having two diverse things, this and this. I don't know if you are getting what I'm saying. That's when we begin to have that ES. Now open bracket, we now have KS plus concentration S, because these are the two different things here. So these two different ones must be in bracket, and then the similar one will be outside. So that when I multiply ES times KS, I will still get this. When I multiply ES times S, I will still get this. I hope you are following. Don't be distracted. Now we have something like this. At this particular point now, we have ES, concentration ES will be equal to KS plus concentration S equals E0 times concentration what? S. Are we together? Now that means ES, to make ES the formula of formula, already you know what to do. We divide by the coefficient of ES, which is what? KS plus what? Concentration S. So we are going to be having E0 times concentration S all over KS plus what? Concentration S. Now, so far so good. This is our equation 2. Look at our equation 1 here. What we did, let me take you back a little bit. Our equation 1, we found our what? Our KS from the first reaction, which is rate of forward and backward. That's our equation 1. Now, to get equation 2, first of all, record our value for total enzyme, and then we made free enzyme the subject of the formula and substituted the value of free enzyme, which is E, in this equation 1. And that's what we've been solving for us to get this ES, which is what? Enzyme-substrate complex. So this ES now will be equal to total enzyme, which is E0, multiplied by substrate, concentration of substrate, all over what? Ks, which is the dissociation constant, plus substrate what? Concentration. Now, during the second reaction, we are done with the first reaction. I told you that this is the first reaction, plus from here to here. This is the first reaction. Now, in the second reaction, we are having this. This is the second reaction, where we have ES to form free enzyme plus product. Okay, this is it here. We are having concentration ES. This is K2. The constant accompanying this process is what we call what? K2. And then we have free enzyme plus product. Now we see that V0, this is a velocity different from Vmax. So we see that V0 is equal to K2S. Remember that for us to actually, produce this, we say that this is the concentration of ES and this is E plus P. Remember that we are talking about constant accompanying the reactant, just as what we did here. Constant accompanying the reactant. Constant accompanying the reactant. Constant accompanying the reactant. When we are talking about backward here, this constant accompanying the reactant. When we are talking about forward, this constant accompanying the reactant. Are we together? So that's the same thing that we did here. Constant accompanying the what? The reactant. Now, substituting this value in equation 1, that is to say, V0 will be equal to K2ES. So imputing that, remember V0 equal to what? K2ES for the what? Second reaction. Constant accompanying the what? Reactant. So we now have substitute now here. We now have V0 equals K2. Anywhere we see ES, this is what we are going to put. Anywhere we see ES, the whole thing is what we are going to put. So instead of writing V0 equals K2ES, we now say V0 equals K2. What is ES? E0 times S over Ks plus S. And that's what we are saying here. K2 E0 S over Ks S. This is Ks, not K2. Ks. Now, maximum rate of velocity of reaction, which is Vmax. Now, in Vmax, what we are saying is, whenever you hear about Vmax in enzyme catalysis, what we are focused on is, at that particular point whereby we have no free enzyme, that's all enzyme has been bounded to the substrate. Remember, here we are having free enzymes. We have what we call free enzymes. That's when we are talking about E. This is a free enzyme. This is a substrate. At this particular point, the reaction has not been to maximum yet because we still have free enzyme, we have substrate. So when we are talking about Vmax, that's the reaction at its highest point, simply means that we don't have any free enzyme. All enzyme has been bounded to the what? Substrate. There is nothing like what? Free enzyme. So at Vmax, we say that maximum rate of reaction, which is Vmax, will be equal to K2E0. Are we together? It's equal to what? K2E0. That's the formula. Remember that we said that V0 equal to what? K2ES. K2ES. And then we substituted. Anywhere we see ES, we imputed this reaction. That's how we started. Now, after we've gotten a particular reaction, which is our equation 3, from what you are seeing here, V0 equals K2 concentration E0, which is total enzyme concentration substrate, all over Ks, which is dissociation constant, plus what? Substrate concentration. Now, we are now getting to a particular point where the reaction can be maximum. And then we say that when the reaction is maximum, we say that Vmax is equal to what? K2E0. Are we there now? We are saying that Vmax is equal to what? K2E0. So anywhere we see K2E0, we replace it with Vmax. So remember in this equation, we have V0 equals K2E0 concentration S all over K2 plus S. So instead of writing this K2E0, what are we going to write? Vmax. You got it right. So we are going to be adding what? Vmax. So we have now that V0 will be equal to Vmax as a result of K2E0. Vmax times concentration S all over Ks plus S. Now remember at this particular point, Ks can be equal to what? Km. And that is why in your Michaelis Menten equation, you can have something like V0. You can have something like V0 is equal to Vmax concentration S all over Km plus what? Concentration S. So this is the particular equation where we have V0 equals Vmax concentration S all over Ks plus what? S, which is what? The Michaelis Menten equation. So this is what we did. This is the reaction. We got the forward and backward, made Ks is subject of the formula. Ks was gotten from K subscript minus 1 all over K1, which is the constant for both the forward and the what? And the backward direction. And then we'll continue, and then we got to here.